Okay. I assume everyone has read the problem statement at the very least. So can you tell me what is the first decision that this company is facing, Renee?
First decision is to test, do the market survey or no survey.
Or not do the survey. Okay.
Yeah, and both of those can have either a positive or a negative outcome.
If I don't do the survey, would I still have a positive or negative outcome? I'm not doing a survey.
No, you have another decision, don't you?
Okay, but we haven't gotten to that one. And just let her answer. John, thanks.
First, if you do the survey, you do have that positive or negative.
Okay, so if we do the survey, then
you have possibility of having a positive or negative feedback.
Positive attitude or negative attitude.
Or negative.
Professor?
Is there any question, Abdullah?
Yes, just a quick question. If we have ever like a decision, can we have like 3 branches?
Yeah, definitely.
Can we have like more than 2?
Yeah, absolutely. I think it wasn't a decision, but I think in the quiz problem, there were 3 options. There were 3 possible outcomes, if I'm not wrong, for the decision. But yeah, when you have a decision point, yeah, you can have as many possible decisions as you want. Most of the examples we did in class are just 2 decisions, but you can have more than 2 decisions at a decision point. And also, when you make that decision, you can have more than 2 possible outcomes. You can have 10 possible outcomes, or as many as you want, or as many as problem needs.
Oh yeah, because that's what it was, like, just confused.
Okay, no worries.
Certain questions like this, it's not given like how much it would cost us for the survey. How
That's
can we
fine. Then
determine
put
that?
0. If you don't have that value, then maybe the survey doesn't cost anything. So don't make up numbers. If you don't have that, just put 0.
Perfect.
John, do you want to give me the monetary value associated with the first branch? We do the survey, the result is positive, we build in Indiana, and the result is moderate.
Okay, that's what you have for the first one. That's 500 million.
Can you tell me what did you, so the monetary value for each card is 30K
Oh,
minus
30K minus minus 16,000.
okay, multiplied by
Sorry. My
50.
tree is different than yours, so I'm trying to just figure out. Times
No.
50,000.
Yeah.
And then minus 200 million.
Where did you get that part? Oh, that's the cost area. If you build in Indiana, minus 200 million. And what is the value, the final value?
500 million.
500 million. Do you want to give me the second one too? So again, the revenue of each machine is 30K minus
24,000.
24.
Times 100,000, and then minus the 200 million again for $400 million total.
Okay, great. Abdullah, do you feel better now with how do you read the number? Do you want to give me the number for the next branch? So first of all, for each machine, we
So
have
for Georgia, we will have 30,000.
moderate 30 minus
22, sorry.
22. How many of the
And then if we have it as a moderate, we'll have 50 times 50.
50,000.
50,000.
And what is the cost?
And then the cost would be 400 million.
For building the factory. And what is the result? Or do that later. We calculate the results later. How about the next branch is strong?
So for the next branch, it would be 100,000 times 30 minus 20 minus 400.
And then 100,000 minus 400 M. John, can you tell me what is the value of the third line?
Third line, I'm just trying to figure out where it is on mine here. That is 0.
And the next?
600 million.
Okay. Hans, you're not still here, right? And William, you're not here? Okay, these are people who log in and go. Giovanni, are you here? Giovanni? Jillian?
Yeah, I'm here.
Okay, can you tell me the monetary value of the next branch?
I'm still actually like trying to map out stuff too. My internet's been kind of in and out, so I haven't been able to closely follow.
Okay, Lauren? Are you here, Lauren?
Yeah, I'm here. Sorry, I just had to unmute myself.
No worries. Can you tell me the monetary value?
I mixed up some numbers, so I had to.
Do you have the monetary value of the next branch?
I don't have the total yet, but I know it's
Just tell me the instructor to the value. 30K minus.
Yeah, so it's negative 200 million, and then or the 50,000 first,
No, it's 30K minus 16K multiplied by.
and then 50,000 times that, and then minus the 200 million.
Minus 200 million. And how about the next branch? Again, I have 30K minus 16K multiplied by a strong cell. 100,000 minus 200 million. John, can you tell me what is the value of these two branches? John, are you here?
It's kind of hard to hear.
Just how like I send you stuff.
Yeah. You do that?
Yeah. She would do it all the time, but then now it's just completely shut off. I'm like,
You okay?
Justin, you're not muted.
Guys, please mute yourself. Sorry guys, my internet today is playing crazy. In the morning class it was fine. I don't know what's going on. Anyway, John, what is the value of these two branches?
Well, it's a repeat of up above, so 500 million and 400 million.
Oh, that's true. And then for the other two also is the same, 0 and 600 million.
And one thing I realized, all of those upper ones that we've worked on should have like a minus S for the cost of a survey on them.
Okay, just let's put 0 for now.
Okay.
Okay, that's fine. Your point is correct, but it's okay if you consider it just 0. Let me see here.
Well, doesn't it cause a problem with the bottom, making it exactly the same cost that way?
No.
Okay, I haven't finished it yet, so.
Okay. Annalise, are you here?
Yes, I'm here.
Okay, can you tell me the value of this specific branch?
Yes, so I have 30,000 minus 16K
Okay.
minus the 200 million.
Multiply by what?
200, 50,000
Minus
200 million.
the result is
500 million.
and then the strong version is
100,000 times 30K minus 24K.
that is 400 million.
Oh,
I think the
400
first one is
million?
500.
Yeah, the first one is 400, yeah.
And then for the other ones is 0 and is 600 million.
Mhm.
Okay. So now let's calculate the probabilities that we have to put on each one of these branches. Frederick, are you here?
Yes, I'm here.
Okay. So let's assume I'm going to call it probability of survey positive, and this is probability of survey negative. Can you tell me for this specific branch, what is the probability? If you just want to write it based on the notations.
There should be 0.3 and 0.7.
No, just tell me in terms of the notation. How do you write it? Probability of?
Oh, probability
moderate,
of yeah, and intersection of
not intersection, given?
is given positive.
sales positive.
Yes.
Okay. How about this one at the bottom? What is this one?
This one gonna be the same probability of
Sales is strong.
yeah, and given
Survey says
surveys are positive.
exactly. Okay. For this one,
probability that it's moderate, given that it's that the survey was positive.
probability that the cell is strong, given that the survey is positive. How about for this branch?
Probability that.
Sorry, that's the decision. How about this branch?
Probability that it's moderate given the negative survey.
Survey is negative. And how about this one?
Probability it's strong given the negative survey.
Okay. Anthony, you are not here. Anthony, are you here?
Yes, I'm here.
I asked you earlier. I couldn't get an answer.
Yeah, I answered earlier.
Okay. So can you tell me the probability of the next one?
Yes. Probability of moderate given a negative survey.
And the next one?
Probability strong given a negative survey.
That's true. And how about this branch?
Probability of moderate.
Exactly. And this is probability of?
Strong.
And this one? Moderate.
Yeah, same thing.
And probability of strong. Okay, thank you. And okay, so now let's see what is given to us in the problem. When you read the problem in the first paragraph, toward the very end, it says, however, they predict that there would be about 60% chance of strong cells and 40% chance of moderate cells. So what are those probabilities? In terms of the notations that we have in the R3, what are those probabilities?
Probability of S and probability of M.
Okay, probability of a strong cell is 60%, probability of negative cell is 0.4. Perfect. And at the bottom, I have that for at the third paragraph, for vehicles that eventually had strong cells, the marketing survey indicates positive attitudes toward the design 70% of the time and negative attitudes 30% of the time. Brené, do you want to tell me how do you write that part? Do you know which line I'm looking at?
Yeah. Sorry, I was muted. So if I'm reading it correctly, it says that for vehicles that were eventually had strong sales, the marketing survey indicated a positive attitude of 70% of the time. So that means that positive survey given strong sales.
Okay, so but when you read that sentence, which one of them is the one that you know for sure? For vehicles that eventually have strong cells, the marketing survey would also say positive attitude 70% of the time. So which one of them is the one that is given to you?
So I would say that they gave us the probability of positive survey given.
No. So this is what you have for now. Just look at the sentence that we have. For vehicles that eventually had strong cells, the marketing survey said positive attitude 70% of the time. So which part of this sentence is given to us for sure?
We're given the positive survey, the positive attitude, 70%.
Okay, 70% of what?
70% the probability of strong sales was 70% when the survey was positive.
No, I hope I didn't confuse you because initially you said it correctly, but I want you to read it one more time.
Let's see, try it again. So for vehicles that eventually had strong sales.
Okay, that's the fact. That's the part that we know.
Yeah.
Condition that they have strong sales.
So it's probability of positive survey given they had strong sales.
Yeah. So that's the part I was trying to ask. Which part of it we know for sure?
For me, this is the hardest part.
I know that's the part that I said is not trivial. So that's why I asked you guys, and just by reading it correctly and doing more examples, you guys get a hold of it easily. So this is probability of positive sale. If I know positive attitude. Sorry. Probability of survey saying positive attitude given that the sale has been success and has been strong, and that is 70% of, right? That's 70% of the time. Can you tell me? Go ahead.
Oh, and then the complement of that. Sorry.
Is there, okay, Rene, wait for a second. Is there any question?
Yes, just for the probability of n, you mean probability of m, right? Probability of moderate, not negative, right?
Yes.
Perfect.
No, this, yeah. My bad. Yeah. This is probability of strong cells and moderate cells. Thank you, Mohammed. Thank you, Abdullah.
No worries.
Okay. Rene, can you tell me the complement of this probability?
So the complement is the probability of negative survey given strong sales is 30%.
Negative given the strong. Remember, for the complements, we never change the condition part. We always change the left part. And that's 0.3. Okay, Rene, tell me the next one. For vehicles that eventually had moderate sales, the marketing survey indicate positive attitudes 20% of the time.
So now that I know how to read it, it goes eventually had moderate sales. So that's the conditional, the conditional part. So that means that positive survey given moderate sales.
Okay. For vehicles that eventually had moderate sales, okay. The marketing survey indicated positive attitude.
20.
What percentage? That's 20%.
20%.
Yeah. What is the complement of this one?
The probability of negative survey given moderate sales is 80%.
Exactly. Okay. Thank you. So these are the ones that we have in the problem statement. Those are the ones that we have. And the blue ones on the decision tree are the ones that we need on the decision tree. So are the ones that we have on the problem statement equal to the one that we need on the decision tree? Look at the conditional probabilities forms. Are they equal to the ones that I need on the decision tree?
Nope.
No. Because, for example, on the decision tree, I need probability of S condition on SP, but here I don't have anything like that, right? So the ones that I have in the problem statement are not equal to the one that I have on the decision tree. So I have to calculate the ones that I need on the decision tree using the ones that the problem has given to me. So I need to use the Bayes theorem. So let's calculate the first one, this one. Probability of moderate sale given that the survey says positive attitude. So how we are going to calculate this one? Write down the conditional probability form. How are we going to write that?
I would write it as the probability of M intersecting SP.
No, let's write it just based on the conditional probability formula. So this is M intersection SP, right? Yeah. Divided by probability of
SP.
SP. That's just the simple definition of conditional probability. Now, remember I told you last time that you can write the numerator in two different ways. What are those two different ways?
That is equal to the probability of SP intersects M.
Multiplied by probability of?
M.
What is the other way?
The probability of M given SP multiplied by the probability of SP.
Which one is the one that I have to choose?
We have the probability of M, so the top one.
And also I have the probability of SP condition on M.
Yeah.
Right? So I pick the first one. So then I rewrite the numerator as probability of SP condition on M multiplied by probability of M. And how about the denominator? How can I write that part? Probability that the survey says positive. If you look at this one, overall in this problem, this thing has been conditioned on two things. Either the sale is strong or the sale is moderate, right? So I just have to condition on these two possible things. So I said the probability that the sale is, that the survey says positive attitude, condition that the sale is strong, multiplied by the probability that the sale is strong, plus probability that the survey says positive attitude, condition that the sale is moderate, multiplied by the sale A being moderate, right? So if you want to just find out on what to condition, just look at what we have in the problem statement. The whole SP, the survey positive thing has been conditioned on two things. Either the sale is strong or the sale is moderate. So we have to condition on those two things. Does that make sense?
Yes.
Okay. So what is the numerator? What is the value? Probability of SP condition on M is 0.2 is this one. Probability of M is 0.4. Probability of SP condition on indices again 0.2 multiplied by 0.4 plus probability of SP condition, sorry, SP condition on S, my bad guys. SP condition on S is 0.7
And 0.6.
multiplied by 0.6 plus, and that one is 0.2 multiplied by 0.4. And what is the final number, John?
Almost there.
What did you say?
0.6.
Almost there.
0.16?
Yes.
1.6. Okay. And what is the complement of this? The thing that we calculated?
Probability that the survey said it's positive when it was positive.
No, the complement of this. The complement.
Strong.
The strong cells if
the
survey is positive. And that's 1 minus 0.16, and that's 0.84, right? So now let's go back to the decision tree and see where do we have these probabilities. So here in this branch, I have 0.16, and here I have, let me write this with green. And here I have 0.84. Did I write it correctly? Strong given SP? Yeah. Okay, so this branch is 0.16 and this branch is 0.84. And how about this next one? Do we have that one?
No.
Why not? I have the moderate condition on SP.
We have that one for the next branch. It's the same.
Yeah. And then this one is 0.84. And how about this one? Do I have that?
No.
No, you have to calculate this one. Probability of moderate, condition on survey says negative. That's probability of moderate and survey says negative over probability of survey says negative. So if I want to write it, that's probability of survey negative, condition on n, multiplied by probability of n, divided by probability of survey says negative, condition on n, multiplied by probability of n, plus probability of survey says negative, conditional on s, multiplied by probability of s. So for this one, guys, make sure to write this formula yourself and make sure you get similar numbers. So probability of survey says negative, condition on n, 0.8. Oops. Probability of n, 0.4. Plus services negative condition on strong cells, 0.3. Probability of strong cells is 0.6. Do you guys know the number?
0.64.
And tell me what is the complement of this?
Strong, given that the survey said negative, which
The
is
survey
0.
is strong given that the survey is negative, and that's 0.36. So let's go up to the decision tree. So this is 0.60, what was the number? 0.64. And this one is 0.36. This one is 0.64. This one is 0.36. Okay, we are good with that part. And then how about here? Probability of 0.4, right? And
yeah, 0.4 and 0.4.
Probability of strong cells?
0.6.
0.6, 0.4, 0.6. Okay. And then the last thing, that now that we know the final value, monetary value associated with each terminal branch, and we also know the probabilities associated with each terminal branch, all we have to do is to calculate the values of the branches and just do the backward calculations, go from right to left. And that's something you all can do, right? And then finally find out what would be the best decision if we end up at any one of these decision points.
No market survey.
Huh?
I think the answer would be the no market survey.
I don't know. You have to, I don't know the final answer, but you have to just do the calculations and find out which one of the branches would work. But I'm just making numbers here, so because the class time is over, so I just want to just show you how to calculate the expected value of sample information. So let's assume if
I have the numbers if you want.
For which one?
Okay. The market survey, we will have 426 million. And for the no market survey, it would be 460 million.
460?
Yes.
Okay. Let's do the calculation. When you guys do the calculations, at the very end, these are the numbers that you have to get. And if you don't get this number, the blame is on Abdullah. And so, but now let's assume we have received these numbers, okay? So remember when we wanted to calculate expected value of sample information, we said calculate the value of the branch in which you do the survey, but you are not paying anything for it. That's 426 million. Is there any question, guys? So minus the value of the branch where you don't do the survey, that's 460 million. Okay, so that would be minus 34 million. So what it means when the expected value of sample information is negative, meaning that it doesn't matter at all, like there is no value in this extra information that you get. Whatever they charge you, you are going to pick the option of not doing the survey. Okay, so no, whatever they charge you, still your option is not to do the survey. So there's no value on expected value of sample information.
If it was a positive number, that would be the most we would want to pay for a survey.
Exactly. So yeah, if let's say if what color can I be? Let's say here. So if by an example, the top branch was, let's say, 500 million, and the lower branch would be 460 million. Okay, then we calculate expected value of sample information as 500 minus 460, and the result is 40 million. That means you are willing to pay up to 40 million for that survey. Okay, you definitely are going to put the option of doing the survey, and obviously here you are not paying anything for it, but even if they are going to charge you, you are still willing to pay up to 40 million for that survey. If they charge you anything more, don't pay for it. Just don't do the test. Don't do the survey. If they charge you anything like 40 million, then do the survey.